This is the Chapter 7 quiz review videos. As you can see, number 1, 2, and 3, you're all given a set of linear inequalities and asked to graph them. This is where your dashed versus solid lines and your shading and everything will be graded by hand. So you get partial credit, but it means you've got to be very careful to get all the little things right. These first two equations are already set up for you, okay? So I would just graph them by hand. You can put them in the calculator if you want, but I would just graph them by hand. I'm going to make this my red equation here, and it starts at -3 because this is my y-intercept here at -3. Then we have a slope of -5. That would be -5/1. So I want to rise 5 and run -1. 1, 2, 3, 4. +5 up in the air, -1. Double check this because we want a negative slope, and indeed when I connect these two lines, I'm going to get a negative slope, or these two dots, okay? So I get a line that looks something like that. Now, this is supposed to be a dashed line. Anything that does not have the or equal to sign underneath it should be a dashed line. I just go through and erase part of mine because I have a tough time drawing a nice straight dotted line, okay? Now, you can go ahead and shade this if you want. I tend to wait and I shade after I'm done with both lines, graphing them, just because it's a little bit easier for me. So I'm going to go ahead and graph this second equation. I'll make it my blue equation. It starts at 1, and it has a -1/1 slope. You can put the negative sign on either piece, okay? I want to rise 1, so +1. That means I'm putting my negative slope down here. Rise 1, run 1. Rise 1, run 1. Again, double check yourself. Make sure you're making a negative slope, and we are. Okay? That would be this line right here. Now this one needs to stay solid because it has the or equal to symbol under here. Okay? So now it's time to do our shading. Our red equation, we want to shade below it. You can also choose a test point. I'll show you how to do that on the next one. For the red equation, we want to shade below it. So that's down there. Down there, down there, down there, that's below. And for our blue equation, we also want to shade below. So down that way, down that way. So I just went along the blue line, writing arrows to show my shading. Now remember, this always splits us into 4 sections. 1 section, 2 sections down here, 3 sections right there, or our 3rd section, I should say, and our 4th section up here, 4th section, okay? We want to know which one is double shaded. This one is only shaded with the red, so that one's out. This one is only shaded with the blue, and this one isn't shaded at all. So our section that is double shaded is right here. Everything under the blue line right here, and then under the red line right here. So anything in there would be a solution. Anything in there would be a solution. You can very clearly see where my actual shaded portion is compared to my single shaded portions. Make sure on the quiz yours is like that. Make sure it's very clear where you want to shade. I've seen some people, and I should probably get used to using this, but I've seen some people use the highlighter to do this before. And they just kind of shade like that. There you go. That's our shaded section. Not perfect, but just another way to do it. Okay? I tend to just shade it in by hand. Number 2, things changed a little bit because now we don't have y by itself, so we have to do a little bit of work first. My first equation is 4x minus 3y is greater than -6. To solve this for y, I'm going to subtract 4x from both sides. I'm going to get -3y is greater than -4x minus 6. And then I got to get rid of this -3. And this is a good little review of something we haven't seen in a while. Whenever we divide by a negative number, we flip our inequality sign. -4 over -3, that doesn't simplify. It leaves us with just a 4/3 x. -6 divided by -3 is a +2. I go to graph this equation, start at 2. Go up 4, can't go up 4, go down 1, 2, 3, 4, left 1, 2, 3. There's my line, right through these 2 points. Because this is a not equal to, I want it to be dashed. Second equation, red equation. X plus 3y is less than -9. That would be 3y is less than negative x minus 9. That's subtracting x from both sides. Divide by 3, divide by 3. Y is, watch this, less than. So that sign didn't flip. You're like, wait, why didn't that one flip? We didn't divide by a negative number this time. Only when you divide by a negative number do you flip the sign. Negative 1x over 3 is a negative 1/3 x minus 3. So we're going to start this one at negative 3, and we want to have a decreasing slope of 1/3. So we want to rise 1, run 1, 2, 3. Alternatively, we could go down 1 and then 1, 2, 3 to the right. Either one of those works. This one also did not have the or equal to piece, so we need it to be dashed. Now, when I go to shade my blue equation, I'm going to do this one by showing you a test point, okay? What I mean by a test point is you can choose, let's just talk about the blue equation, so we're going to do this in blue. We can choose a point on either side of this line and test it. If it works, we shade that side. If it doesn't work, we shade the other side, because it's got to be either this side or that side. And I always, if available, choose the point 0, 0 as my test point, okay? Well, when I plug 0, 0 into this equation, I get 4 times 0 minus 3 times 0 is greater than negative 6. That would be 0 is greater than negative 6, and that's a true statement. So that means I'm going to shade everything that has the point 0, 0, everything on that side of the line. That would be this side of the line, so I just shade everything on the below side of this. Last time we did that by looking at the sign. The sign can be tricky. Make sure you look at the very end. Less than means below the blue line. Okay, same thing. We just did it with a test point this time. We're going to do the red one with a test point. Right here, we plug a 0 in, we get a 0. Plug a 0 in here. 3 times 0 is just 0. 0 is less than negative 9. Okay? 0 is not less than negative 9. That was false that time, which means for the red equation line, we're going to shade everything below it as well, because we don't want to shade 0, 0 here. Because 0, 0 failed, so we, instead of shading towards it, we shade away from it. We look for our double shaded region. This is single shaded. It's a small section, but it's single shaded. Not shaded at all, only blue. Our double shaded region is down here in the bottom. This little almost triangle shape. Okay? That's our double shaded region. Double shaded. Number 3, again, we have to solve these equations. These ones already in my mind start sticking out though, because I see how similar they are. Okay, just something to remember for later. We have 5x minus 2y is less than negative 4. We solve this for y. Negative 2y is less than negative 5x, because we subtract 5x minus 4. Divide by negative 2 on both sides. I get that y is greater than 5/2 x plus 2. Negative 5 over negative 2 is just a 5/2 x. We're okay with that being a fraction. It is a slope. Negative 4 divided by negative 2 is a positive 2. We graph that by starting at 2. We can go down 1, 2, 3, 4, 5, and over 2. Double check that. Up 5, 1, 2, 3, 4, 5, over 2. Same thing, positive slope. That would be our line. It should be dashed. No, my eraser not working. There we go. For my blue equation, I have 5x minus 2y is less than or equal to 2. Same set of steps. Subtract 5x. We get negative 2y is less than or equal to negative 5x plus 2. Divide by negative 2. Don't forget to flip the sign again. Y is greater than or equal to 5/2 x minus 1. So now we're going to start at negative 1 and go up 1, 2, 3, 4, 5 over 2. And our suspicions have come out to show us that we had parallel lines all along. Okay? But this is not like when we had systems of equations where parallel lines was like, oh, that's the answer. We still have to shade. We want to shade above the red line. Okay? That would be this way. And also we want to shade above the blue line.